Okay, I started the recording. I guess we can start now.
Okay,
All right. So hi,
sure.
I'm really thankful to you for being in this meeting to help me with my GMO community outreach project for awareness as part of the 4-H National Science Summit, and I'm really looking forward to learning more about you and your perspective of GM. Actually, more about your perspective of GM food. So yes, I did watch the food evolution movie.
Oh, yeah.
It was really cool and very insightful for my GMO outreach project. And it was really great to see your contribution to the GM research field. And I even, as a matter of fact, I even suggested this movie to my own relatives from all around the world. So yeah, it's a really cool movie.
Oh, good. It's on Hulu for free in America, but it's a bit harder to get in other countries. But they can rent it on like iTunes and things like that if people want to watch it. It's called Food Evolution, and it looks in a kind of a narrative storytelling way around the controversy around genetically modified organisms.
Yeah, it was a really good movie. So for the purpose of this meeting, so I just have like a bunch of questions here. So
Okay.
starting off for the question, so I just wanted to understand like your general like level of understanding about GM food, or like basically your overall perspective of GM food.
Well, I'm a geneticist, and so I actually work at the university in genetic improvement of livestock and particularly cattle. But so as a geneticist, I'm pretty familiar with how we've improved the makeup of our livestock and plant food species over time. And I look at the ancient aurochs that became a cow, and wolves that became a chihuahua, and teosinte that became modern day corn. And you can see these dramatic changes that have been made through conventional selection, where breeders have just kind of said, I want my corn to look like this or grow like this, or I want my chihuahua to look like this for whatever reason. Or in the case of food production, more productive, less disease, susceptible animals and plants. And so when I think about genetic engineering, I look at it very much as a geneticist, where we're introducing a single gene quite often that gives the plant or animal a characteristic that's desirable in our breeding program: disease resistance, resistance to insect attack. And I don't see it as this great big kind of red line in the sand that's dramatically different to what we've been doing for many years. But I understand that in the public's perception that some people do see it as a big red line in the sand, especially if you're talking about introducing a gene from maybe a different kingdom than the kingdom that you're introducing it to. So bringing in, for example, a gene from a bacteria into a plant. For some people, that's a real, like, kind of a horrifying thought. Although, I think if we look at my favorite species, the cow, I'm 86% identical genetically to a cow, because we're evolved from the same, basic organisms. And so this idea of a species having its own unique DNA that's somehow different to the DNA of other species is kind of a bit of a strange concept if you think about evolution. So I have a very scientific attitude towards it, because that's my background. And so that's, I think, if you're trained as a scientist, you tend to look at things from a scientific perspective.
For the next question, so do you consider GM food to be safe for everyone?
Well, you used two terms there that have no definition, right? So GM really has no real meaning, but if you're talking genetically engineered foods, then I think you have to look at, well, what is it genetically engineered with, to be able to answer a question as to whether there are any unique hazards, which is how I like to frame it, because there's no such thing as safe. You can't guarantee anything is safe. You can only show that the evidence doesn't suggest harm. And so if I look at genetic engineering, the products on the market, I think that we've got 30 years of data now that show there haven't been unique risks, and so I am comfortable that the products on the market are have not been shown to cause harm. But because it's a tool, it really depends what product you're talking about to be able to evaluate whether there's any unique hazards there. And so it's kind of a trick question. So, prove GMOs are safe when you haven't really defined, well, what's a GMO, and you can't prove safety. So what I can say is the products that have been on the market have gone through rigorous safety testing, and they haven't been shown to be associated with unique risks. And that's kind of a sciencey way of saying they're safe. But no scientist will ever say something is 100% safe, because you can't really prove that.
Yeah, so like it really depends on like each product, as you're saying, right? So.
Right. And I think conceptually, if a protein is toxic, like, I don't know, botulism, let's just say, is really, really toxic protein. If for some reason you wanted to express that protein in a corn plant, you could make a really, really dangerous genetically engineered botulism corn plant if you chose to do that, But if you look at the safety, and particularly the insect protected crops, where you protect the crops from insect damage, those crops actually have a much lower level of aflatoxins and really toxic byproducts of insect attack, which leads to mold contamination, which leads to these high levels of these toxins. And so I could even make the argument that, in fact, some products on the market are safer than the conventional varieties because they are protected from those insect attacks. But that's a byproduct of the application rather than because they're genetically engineered. It's because they're not getting eaten by insects is why they don't have, the high levels of aflatoxin.
I see. So now with everything that's going on in the world right now, especially for GMOs, all the commotion and everything, so do you think there's enough information available about genetically engineered food, according to?
There's 30 years of research data and, report after report after report after report from the National Academies of Sciences and every scientific society in the entire world. So I don't think there's an absence of data that's causing the mistrust of genetic engineering. And that's really frustrating for scientists to acknowledge, that actually people don't make up their mind based on data. They often make their mind up based on emotion and often depending upon their peer groups and what their peer groups tell them. And I mean, we see similar things happening to the kind of the conspiracy theories around COVID and vaccinations, and where you can have blatant misinformation that gets kind of narrated into factual information, and then you get this big conspiracy theory brewing. And so I think that, unfortunately, the emotional appeal, and especially fear, is a very easy emotion to get people whipped up about. So if you suggest that, for some reason genetic engineering is hurting your children or something, that's a really easy kind of emotion to get ripped up. And it's a lot harder to reassure people that actually it's fine, and vaccines are actually fine, than it is to get them scared or something. And so it's hard to counter misinformation and fear with science-based information. So there's plenty of information, and it's very frustrating to have the internet available now, freely available, and yet people seek out information that's just not correct. They, instead of going to .edu or a .gov, they go to some Facebook group of kind of people with like mindsets that is not based on data at all. And so you get these kind of crazy ideas that get spread around like so quickly.
So I was just wondering, so the other question, so I was just wondering if you read food labels or labels on food products?
Me personally? Yeah, I read them for the information that's important to me, which is the nutritional information. And that's mandated on the back, how many calories, how much protein, blah, blah. But I guess if your question is labels about how food is produced, then you don't want to go shopping with me, because I know a lot about agricultural production, and a lot of the labels that are kind of virtue signaling, or that a lot of consumers might gravitate towards because they've been told that that label is more sustainable or whatever. If you actually know the data, I actually will avoid some of those types of labels, and I'll absolutely avoid labels that are nonsensical. GMO-free water is just a nonsensical thing, and it just offends my scientific brain that people are marketing on consumers' fear with these absence labels that don't make any sense, because there was never DNA in water in the first place. And that, to me, is marketers that are capitalizing on basically the consumers' lack of basic biological understanding, and capitalizing on fear to increase their market share. And that is a pretty disingenuous way to make a living, in my opinion. Rather than trying to help people understand, to actually prey on that fear and make money from it is pretty bad.
All right. So, what do you think is the main benefit of genetically engineered foods?
I love that you changed what you called them. I guess, again, it depends on what the application is. So, depending what characteristic you've given a crop or an animal, then that will be the benefit. So I think if you look around the world, probably the easiest one to quantify is the insect protected, the BT crops that are grown in many, I think there's like 18 million farmers now that grow genetically engineered crops globally, and about 16.5 million of those are in the developing world, in China and India. And that insect protected cotton particularly has dramatically reduced insecticide use, because basically the cotton is protected from caterpillars. And so you don't need to treat with insecticide if the caterpillars are not there. And it's kind of common sense that that would be the case. And so if you look at the dramatic decrease in insecticide use that's been enabled by that particular application, I think it's a very clear win. And there are other things like disease resistant, the papaya in Hawaii, for example, that was part of the Food Evolution movie. That industry was gone because of the mosaic ring spot virus, and basically they inoculated the plants, and now they're no longer susceptible to that virus. And at this stage, I think we should all appreciate the importance of inoculation and viruses, right? And so wouldn't it be nice to have a virus, an inoculation that was protective from COVID at the current time? So to me, those types of applications that reduce the use of chemicals in agriculture really align with almost like everybody's values. I guess I see no downside to trying to develop applications that reduce the use of chemicals in agricultural production.
Okay. So the next question. So what do you think is the level of responsibility that farmers have in order to ensure that their genetically engineered crops are safe?
That the farmers have, wow, I guess I don't really see that as the farmers' responsibility. I see there's a rule in America, and I think most countries, that you're not allowed to sell unsafe food. And so irrespective of what breeding method was used to produce it. And if a farmer's buying seeds that happen to be whatever, insect protected or disease resistant, then to me that the responsibility there is that the seed company that's selling that variety, whether it's genetically engineered or not, and this happens in conventional breeding, they have a responsibility before commercializing it to make sure that the product doesn't have any unique risks. And so there's actually some really classic examples in conventional breeding where breeders selected for, I think, certain varieties of potato, if I'm not mistaken, that actually increased a naturally occurring toxin. I think it's solanine, if I'm not a huge plant person, but there's a lot of toxins in plants. Plants have evolved to not be eaten. That's really their defense mechanism. And so a lot of naturally occurring chemicals in plants are actually toxic at high levels. And so breeders have to be careful to make sure the varieties they select don't increase these anti-nutrient properties of crops, whether it's genetically engineered or not. So I guess to me that the responsibility for safety falls on the commercializer, whether it's genetically engineered or not. I mean, farmers' responsibility is to make sure that they're not using chemicals in a way that's off-label or at higher doses than what's been deemed by the EPA to be an acceptable tolerance level, those types of things. And they have a responsibility for good management, but not, I wouldn't say, for the original product's safety. That kind of belongs to the seller of that product.
See. So I was just wondering have you ever bought organically grown foods? I was just wondering.
I'm never going to say never, but I don't make a habit of it. I am very interested in the sustainability of agriculture, and I think when I look at the yield data, I don't believe that having less efficient agricultural production is in the long-term sustainability interests of the planet. And so I also have some issues with prohibiting the use of technologies, whether it's genetic engineering or treatments for sick animals, that I just think I fundamentally don't think that's the right way to deal with disease, and so I'm not a huge fan.
All right. So right now, how common do you think that genetically engineered foods are in the U.S. or even the world now?
How common are genetically engineered foods? Well, there's only, I think, 10 or 11 species of commercialized genetically engineered crops. And the big ones, of course, are corn and soy and cotton and canola and those ones. And so if you're looking at raw foods, there's not a lot of species that have been genetically engineered, but because they're big broadacre crops and oils and soy lecithin go into a lot of processed foods, I think the estimate I've seen is something like, 70% of processed foods in the US supermarkets are likely to have some ingredient derived from genetically engineered crops. And it's like, okay. I think it's kind of ironic. You're probably familiar with the Impossible Burger. It's a soy-based burger that is being developed that has an additive that's like a hemoglobin substitute that's developed in genetically engineered organisms. And so that product is quite proudly contains genetically engineered ingredients, and it's sold without any problem or at all. And so I think this idea that consumers will reject genetically engineered food if it contains genetically engineered ingredients actually isn't backed up by that particular example. And it's really given the safety testing and everything, there's no safety difference in the products. And so when you see groups that are trying to drum up business by labeling their product as GMO free, again, they're kind of marketing on people's ignorance and fear and making money from basically trying to scare you away from safe products to buy their more expensive absence labeled products. And I think that really is capitalizing on not a great way to make a living, I guess.
Right. So, do you think labeling of GMO should be, genetically engineered food should be necessary for out there in the grocery stores?
Yeah, I hate the labeling debate. I mean, there's a law passed now that it has to be labeled, so it will be. So can we be done with this discussion? Because it's like, it's just, it's a breeding method, you know, and so it's a meaningless piece of information. It doesn't relate to anything to do with food safety or food nutrition. It's a breeding method. So, you know, as a scientist, I fundamentally reject the idea that you need to label for something that doesn't have any material relationship to the food. But if it will stop people talking about it, then let's just label everything and then we can get on with our lives. You know, if the money that had been spent on the labeling initiatives and the billions of dollars it's going to take to label everything as to whether it contains genetically engineered ingredients, if that had been invested in research to improve the sustainability of agriculture, that could have done so much good. And I think that's what frustrates me is the good that could be done with that money that's being wasted to put a label on there that's meaningless and doesn't tell the consumer anything. It doesn't even tell them whether it's been genetically engineered to be disease resistant or you know, insect resistant. It's made using this particular breeding method. Well, it doesn't serve a useful purpose.
Right. So when it comes to genetically modified food, so do you like care about the nutritious level of all the food that you buy?
Well, I care about the nutritional level of any food I buy, whether it's genetically engineered or not. That's why, to me, the food label that's important, and quite frankly, the reason that you eat food, or at least the reason I eat food, is for the nutrition that's in it. And so hopefully it tastes delicious too. But if there is no nutritional difference between genetically engineered varieties and conventional varieties, then the label is not going to reflect any nutritional difference because there isn't any. Although I will add that there's quite a lot of genetically engineered vitamins that are produced. And so if you look, I remember Cheerios a few years ago, you know, the little rings that you give your kids, they decided that they wanted to have a GMO-free label. And so overnight, they put a GMO-free label on there and they removed a whole bunch of vitamins from that cereal. And so they made it less nutritious because they couldn't use this genetically engineered derived vitamins. And so to me, that's going the exact opposite direction of what we would like, which is for our foods to have, you know, improved nutritional composition, not less. So that's the exact opposite direction that we want to go.
Right. And I was actually going to ask this question, but from my understanding, so you said that it depends. So like so I asked before if there are any risks or benefits for genetically engineered foods, and you said it like depends on the product, right? Mm-hmm. So I was gonna ask if the benefits of genetically engineered foods outweighs risks, but again, that would like depend on the product, right?
Yeah, I mean, I think you can look at the history of what has been commercialized to date, and you can see a big decrease in particularly insecticide use, a big uptake in no-till farming, a big increase in farmer income, especially in the developing world. And I mean, the BT, it's eggplant in Bangladesh, it's the benefit to those smallholder farmers has been tremendous. They used to spray some crazy amount, like 30 times a season or something, and the eggplants would come to market with a sheen of like insecticide spray on them, and they've basically eliminated the need for that, and that's obviously saves them money and it's good for the environment, and they are bringing home more pay. And so that's kind of a triple win for the environment. And so it's always perplexing to me that there can't be a more nuanced discussion about the fact that some applications actually do benefit the farmer, the environment, and they have a triple win. And yet there are, you know, certain production systems that just flat out ban the use of these technologies, even if they, you know, disease resistance to me totally aligns, for example, with organic philosophies, like selecting disease resistant animals and plants should be, you know, not to part of the DNA of organic agriculture, and yet they forbid the use of this technology. And so that's not, it's internally inconsistent to me, and it doesn't make a lot of sense. So what's going to happen if you don't have disease resistance? Well, you have to do something about the disease. And so how you deal with that is often using chemicals, or the plant dies or the animal dies. And that's not great for sustainability or farmer income either. And so those trade-offs, I think, is what's missing in this discussion. So what's the problem we're trying to solve? And then what are the solutions to that problem? And there'll be different, genetic might be one, and chemicals might be one, or, letting the animal die might be one, whatever the solutions are. And then we can have a rational look at, well, what are the costs and benefits associated with each of these different solutions to that problem? But just banning genetics as being one of the solutions doesn't address the problem, and the outcome, which in this case perhaps is not allowing genetically resistant animals to come to market, that outcome, which is basically doing nothing, may be worse than the outcome of allowing those products to come to market and stopping the disease. So I think that those trade-offs are what's missing, and a lot of people aren't even aware that, I don't know, insects eat crops, and animals can get viruses, although hopefully COVID has helped people understand why biosecurity is so important on livestock operations, and why farmers go to great lengths to make sure animals are vaccinated and that they don't allow exposure to viruses. And so that's part of normal agricultural production, to try to minimize virus transmission. It's a little bit ironic, because a lot of the measures that farmers implement to prevent disease transmission between, for example, dairy calves, is social distancing, washing your hands between feeding one calf and the next. It's everything that we're doing now for COVID. And so biosecurity is kind of old hat to livestock farmers, that it's becoming rediscovered with the human population at the moment.
And this next one, actually, I think it goes back to your Cheerios example, where they made GMO-free or genetically engineered food free. So you said that because they removed the genetically engineered part of the food, they removed like a bunch of the nutrients, right? So
it was, yeah, so there are particular vitamins that are made using genetically engineered bacteria. So it was those that were, to get the non-GMO label, they had to basically no longer add those vitamins. And so there's not, I forget which ones, but let's say vitamin E. There's not, oats is what Cheerios are made from. So there's not, normally vitamin E in oats, or I don't know if I've got exactly the right vitamins. So they would add it, and that's great for the nutritional composition of that product. But to basically put this label that means effectively nothing on a product that was made from oats, there's not even any genetically engineered oats, to put that label on there, they had to basically remove the thing that was good, which was, improved nutrition, vitamin profile of oats. So it's, but that wasn't advertised. And so consumers, they see that label and they think, oh, that must be healthier for me. And it's deceitful, and it's not helping consumers understand what the implications are. And it's putting, it's kind of greenwashing a product to make consumers think it's better for them, but in fact it's actually got less nutrition.
I see. And with the vitamin removal, because the vitamins are like pretty healthy, even if they're like genetically engineered. So I was actually going to ask your thoughts about health in terms of genetically engineered food, but like based on what you just said, so like you think that it should be healthy, like for the most part?
Well, I mean, most of the products on the market are not different to the conventional varieties. So the term of art is not substantially different. So they're not healthier and they're not less healthy. Other than that example I gave you earlier, where if it's insect protected, it has, corn often has lower levels of aflatoxin, but that's not directly because of genetic engineering. It's because the insects aren't eating them, so they don't get mold infestation. But there are some products that are designed to be nutritionally fortified, genetically engineered products. And so there are groups working to, for example, increase vitamin A level of rice. You've probably heard the famous golden rice, where the intention is actually to intentionally produce a product that produces its own vitamin A. And that actually is a nutrient that's deficient in the diet of many children, especially children in the developing world that are primarily eating rice. And so it potentially could help the health of those children. So it depends again on the product that you're talking about. But most of the ones that have been brought to market in the US tend to be traits that help with the production of the product, so don't get diseases or protected from insects, that type of thing.
All right. So yeah, I actually have only one more question for the
Okay.
discussion, and this one is it's not too different, but okay. So like, the thing is, how do I exactly reach to my community by creating awareness about genetically engineered foods? Like, not in terms of like how to physically do it, like with like a device or like what, like I don't know.
Yeah,
Like,
it's a really good question, and I think that science communicators are really struggling at the moment with the misinformation around the COVID pandemic, and it's a little bit. Have you ever heard the term Schadenfreude? It's kind of it's agricultural scientists are kind of sitting back and going, we told you so, because we've been kind of dealing with this for about 20 years in agriculture, where ever since I started working in this field, you know, I was kind of, you hear this misinformation, and so, you know, you're as a scientist, I make my decisions based on data and evidence, and so my instinctive response is to try to reassure people with data. And I'm just sure if only they knew, you know, what I know, they would change their minds. And it's kind of, you do that and nothing happens. And you're like, what's wrong with this? You know, what's going on here? Why aren't people changing their minds? And I think that, you know, the science communication literature kind of suggests that you can't go in and tell people, you know, that they don't know what they're talking about, or to be kind of expert, or, you know, I let me tell you everything I know. That you need to connect with them on a more personal level, and I think that's what's frustrating to me, because and I live in Davis here in California, and so most of my neighbors here are urban and don't know anything about agriculture. And so that's, you know, probably my best opportunity to influence people are the mums that I have in the PTA group I go to, where I'm not necessarily an enemy there. I'm a fellow mother who, you know, is trying to coordinate soccer with them. They're the types of groups where you can actually have an influence, because they don't automatically cut you off as being, oh, you are, you know, you're an outsider, you're one of them. And if they trust that you are, you know, a good mother and you're driving their kid to soccer, you know, if you can have a discussion there about where the shared values are around this technology. I mean, most parents want safe food for their kids. Most people want to reduce the environmental impact of agriculture. They want to use less chemicals in their food production. And like, then we have the same goals. How can it be we're coming to a different decision on the same technology? And I think having those kind of nuanced discussions and getting a feel for where people are getting their information from, because quite often if you kind of have a discussion, a friendly discussion, you'll find that people aren't 100% set. You know, there's always activists, and it's like, you don't need to argue with them, but just like the normal people, you know, run of the street people, they're busy with their lives, and this isn't a top of mind concern, and just a little bit of a discussion with someone they see as a trusted friend or you know, fellow parent, you can actually have a much more useful discussion, and try to understand, well, what is your concern about this technology? And quite often what I find is it's not actually the breeding method they're worried about. They're worried quite often about, you know, large multinational corporations or you know, food control or food sovereignty, or something that's kind of tangential and and it's associated with GMOs, but it's not a cause and effect thing. And so they're quite happy for, like, disease-resistant papaya to be developed by a land-grant university and released to the farmers for free. They don't have any problem with that. And so I think that that quite often the narrative gets kind of mixed up with, especially Monsanto, and that you kind of get this big bad business model going on, and there's not a real appreciation for all of the different applications that have been developed by public sector, land grants, small companies to do things like disease resistance. And really that the pushback against it is stopping some of these useful products from coming to market. And so again, we haven't solved the problem. So there's fungus resistant strawberries that I think would be, strawberries are terrible for fungus, and that would be a great product. And yet it can't come to market because of this whole debate around GMOs. And I think that opportunity cost and the trade-offs associated with that are what we have to talk about, because it's of all the industries on earth that affect the environment, agriculture probably has the biggest footprint. And it is, to me, the technology that we most want to use, or the industry that technology is most needed for to try to reduce the environmental footprint of agriculture. The last thing you want to do is hamstring that industry and not allow it to use modern technologies. 1950s agriculture was not more environmentally sustainable than modern methods. And to kind of tell farmers, I want to use, my iPhone, but you have to use, technology from the 50s doesn't make any sense to me. To me, that's not really helping. And people do care about the footprint of agriculture. And so if you can find that common ground, I think that's where you can start having a discussion and listening to what their concerns are and where they're getting that information from. And then eventually you do have to back it up with a little bit of data, but you can't lead with the data. You have to lead with the shared values and how this technology actually does a lot of things that they are actually passionate about.
All right. That's it. So thank you so much
Okay.
for your insight on genetically engineered foods. And I really appreciate your time for this.
I have to ask you a question. Is that a microphone that you have here?
Okay, that's basically, so I'm a Hindu, so I always have to wear that mark.
Okay, and what does it mean?
It's like a typical thing that Hindus wear, like a religious thing. So
okay, yeah. Cool. All right. Well, it was a pleasure to meet you, and good luck with your project.
Thank you so much.
Okay. All right. Bye.
Goodbye.